Matter can be presented in different states: solid, liquid, gas, or plasma. Solid state of matter is characterized by the molecules being closed and bonded through electromagnetic forces. Solids have well-defined shape and volume. Molecules in liquids are also closed, but their bonding forces are weaker, so they can move with respect to each other. Liquids can flow and have a shape of the container. Molecules in gases are not bonded and can move freely. They can occupy the whole space of the container. A gas is also a fluid, as it can also flow. Atoms in a plasma have the electrons moving separated from the nuclei. This tends to happen at very high temperatures, such as happens in the sun. Today we're going to study fluids. We define the density as the mass per unit volume. Rho equal to m divided by v. Some substances such as gold, aluminum, water have a characteristic density. The density of a substance will depend on the temperature and the pressure. In the case of solids, the density changes very little with temperature and pressure. In the case of liquids and gases, it does change significantly, on gases above all. But what is pressure in the first place? Well, we define pressure as the force per unit area. For example, when you are standing on the floor, your weight is a force that is being exerted on the surface that your feet cover. Then that small sectional area of the floor is experiencing some pressure due to you. We can calculate the pressure under your feet. Assuming you have a mass of 65 kilograms, the force is the mass times gravity, which is divided by the area, in SI units, everything, of course. Gives a pressure of 65 kilograms times 9.8 meters per second square divided by 0.05 squared meters. This is 12,740 newtons per square meter. This is in SI units, which also corresponds to 12,740 pascals. Pascal is the SI unit for pressure. And the atmospheric pressure that we experience is of about 1,000 hectopascals. This is 100,000 pascals. Because you have the same weight no matter what kind of shoes you wear, if you go on a snowy landscape with skis, you will sink less than if you just wear your street boots. This is because the skis cover a larger area than the boots, and the force of your weight is the same. It is interesting to calculate the pressure inside a liquid. For example, the pressure if you scuba dive in a lake. The deeper you are, the more water over your head, and the weight of that water is increasing the pressure you experience as you dive deeper and deeper. Let's assume a cylinder of water over your head when you are at the depth h. The weight of that block of water is its density times the volume. I am going to assume that the density of water here is constant. The weight is rho times g times area times h. And the pressure is that weight over the area. So area cancels, and we get that the pressure at the depth h meters is rho gh. Under those assumptions, the pressure increases linearly with depth. The density of water is about 1,000 kilograms per cubic meter, and g is 9.8 meters per second squared. So the pressure due to that water is of about 10,000 times h, pascals. So if your watch says that you can put it at 200 meters under the water, it means that it is watertight to an increase of pressure of 10,000 times 200 2 million additional pascals, which is about 20 times more pressure than atmospheric pressure. Although I wouldn't try to go that deep. May science be with you.